Hi everyone, welcome to lab 11, and in this lab we will be going over how to do the code generation, and more specifically how to do it recursively or use a visitor pattern, and also most importantly is how to do the transfer of the control flow. So more specifically we will be going over the conditional expression, the match or type case expression, and also what's going on with the ARM branch, and also we will be talking about how to do the type checking in MIPS, or how to do that, like how to remember in a branch in a branch of a type case we have to do type testing to see if one expression is of one type, and then continue further and further. Okay, let's start with the first one, conditional. So in the conditional expression, this is the basic layout, and if you see, I missed the colon after true, but true is a label, false is a label, done is a label, and then we have an instruction called beqz. And if you remember, false, the value of the false was 0, and then what am I doing is that if the value of a false, if the actual value of the boolean uh, is 0 or false, we actually we branch to the false label. Otherwise we continue, and then we execute the true, what's going on in the uh, true block, and then we branch to the done. Now one interesting thing here is that beqz branch equal to 0 is a macro MIPS instruction. It gets expanded to something else, to another instruction. Now the trick question is, what is that the instruction that it gets expanded to? beqz, and then it gets expanded to beq, branch equal a0 0 false. Now $0 is a alias for a register $0, register number 0. Register number 0 always holds the value of the 0, and it's hard coded to 0. So it may not look very useful, the register that always holds the value of 0, but it's actually very useful for all these for all the macro instructions. Even there is another macro in MIPS instruction, like move. Move is a macro for add, which uses register 0. uh, Move gets expanded to add, so that's very interesting. But let's go back to the conditional. So when you're writing the code here, you should write the beqz $0 false, or instead of false you should have some helper function to generate a random label. And we have a label true. Again, you should not use a true, you should use a random some helper function to generate a label. And then for the what's going on in the then arm of the conditional, you should just call your recursive function, or do a accept in a visitor pattern. That's what's going on. So you should not go inside the then expression or else expression of the conditional and then write the code over there. You should just call your recursive function or the visit pattern function. That's what's going on. So another interesting thing here is, after we are done with the true or the then block of the conditional, we have to do a be done. Be is a branch unconditionally. Branch unconditionally to the label done. So we don't want to execute the true and then the false. We want to execute true or false. Okay, if that makes sense. Let's continue. So we talked about beqz, and then we found out that's a beq instruction actually. And so there's another way to write that conditional. The trick or the hint I can give you is using branch not equal. And then there's another instruction called branch not equal to 0. Be not branch bn easy, if I said it correctly, but that's a macro instruction again, and I'm not sure about that instruction, but I would go with the safe approach and use the branch not equal. So there are many different ways to achieve the same functionality of a conditional, but with different layouts. And yeah, so it doesn't matter how you write the code, what layout you choose. You choose in your code generation. You you should make sure that it achieves the same result. So the way I recommend is to do it by hand. This is what we are going to do in this lab assignment. We're gonna write all these layouts by hand and then think how we can translate this code into a recursive function, and then translate it into your next programming assignment. Okay, let's continue. So the match expression or the type case, C type case, if you remember it correctly, there is a null branch arm, and if you read the handout in the CS 654 CAS website, the official CAS website for the CS 654, you will see that there is a link for cool manual. When you go to the cool manual, it talks in detail uh, about type case and pattern matching and all this stuff. And one interesting thing when you go over there is null. So when you go over the cool manual, not the cool tour, the actual cool manual, the long version. So when you go over there, you will see that the null arm of the type case or branch, null arm, is optional. But what's happening is that if you don't have it and the expression is null, your code will jump to runtime exception. So again, the user has the option to provide a null arm, but if it's not provided, the and expression is null, the code will go to the runtime exception. Now, the reason for that, and the reason for that is each expression for each arm for each type and expects a value, uh, the refined typed value, the value that we refined its type, uh, to not be null. So if it's null, so we can always safely assume the value that we refined its type is never null. That's the idea, if that makes sense. Okay, so let's continue. So for a match expression, we can see in the following example, we have two arms plus one for the null, and then again the null is optional, but you need to jump to runtime exception if it's null. So we can see that the type of T1 is less than or equal to type of T2. What do I mean by that? Is think of it this way: if the first arm of the branch is any, and then the second one is a string, so it's kind of useless because any covers a string, and we cannot. It makes the following, like the string arm, very useless. So the types as we go, we have to refine the types as we go. So the first one has to be a string, and then the next one can be any, and then the third one can be null, if that makes sense. So we already have done this type checking in the semantic analysis phase of the compiler. So we can safely assume there is no overlap between each arm of the branch, each arm of the type case or branch, each branch arm, and because we have already done the semantic analysis, we can continue. But one thing we haven't done is we need to do it in the code generation, codegen.scala, is we need to see that if there is a null branch arm was provided. If it's provided, you need to use that, and then you need to use that. Otherwise, you need to create another one for yourself. You will see what am I talking about in the next slide. So the basic control flow is you need to first do the code for the null branch arm, and if it's there, first you need to go through all the branches and find the one that's null, the type is null. If there is one, find that. If there is not none, still write the code for that, and then what am I talking about is like a label, and then checking if the value is null or not. Remember, um, you you can check if the value is null or not. Remember, we have a null pointer, so I don't want to give a lot of hints, but we have a null pointer, and you need to check if the value is null, and if it's null and then the null branch was provided, then continue the code and then jump to the end, branch to the end of the match. If it's not provided, then you need to jump unconditionally to the runtime exception. So runtime exception can be just a simple system called 10 that terminates the program. So it can be somewhere, some label somewhere in the generated code that we can jump unconditionally to that terminates the program, if that makes sense. And okay, so you need to have two control flows. If it's provided, the null branch was provided. If it's not, and then either if it's provided, you need to branch to the end of the type case. So you should have a label in the end of the type case. What you should have a label in the end of the layout that continues, and then you branch to the done. Otherwise, continue. And then for each arm, you need to do the type checking. So remember that one interesting thing is that the type of the expression, the static type of the expression, we should not use that. Remember the type of the expression that we have in the compile time, we should not use that. What instead we should do is that we should get the type of each object. And one interesting thing is that each object at offset 0 has a type, and then we can use that. And then the type of each object at offset 0 is, for example, for Boolean, we have a value of 5. And indices start from 0. So what does it tells us? That like for Boolean, when we go to the cast name table, at offset of the cast name table, the label plus 5 times 4, remember the addresses are in bytes, so 5 because the value for the cast tag number for the Boolean is 5, so label plus 5 times 4, we will get to the cast name of a Boolean, and that we can use that. So what you need to do is to see if expression is expression of for example type T1. You need to check if you need to get the type of the expression from offset 0, and then check if expression, the type of the expression is at least T1. So the expression may extend may be type of some other, the expression may be some type foo that foo extends T1. You need to check if the expression is at least type of T1. If that's the case, go with that approach. Otherwise, continue. So you need to continue, and if it's the last one, if it's the last one, if it's any of if and then if it's the last one or any of these branches, we go to the end. Now, another thing we have done in the semantic analysis was we made sure there is no impossible branch. So unlike Java or other languages, we always check for impossible branch. So we never have to like go to the next branch, go to the next arm of the branch, and the next one, and then if it's the last one, and then we don't know what to do. We don't have this situation in code because we always check for the impossible branch. So there's always a case, and there's only one case that we don't know, that is the null arm. So it should be kind of relatively easy. And then after you've done the code, like for T1 or T2, expression for T1 or T2, you need to branch unconditionally to the end of the match, if that makes sense. Okay. And remember that for the expression, like for T1 or T2, you should not write the expression when you are doing the match expression. You should just call your recursive function to generate the code for you on that spot, if that makes sense. So think of the code, think of when you're writing the match expression, or the if else, or the conditional, you need to think about the layout. How do you write the basic things, and then just call the recursive function or the visitor function. the visitor and then to generate the code for you in that spot, if that makes sense. Yeah. So think about when you're writing, when you're going over this lab, there is a lab exercise that you need to turn in. Is you need to think about the layout, and that's the most important part about this lab, just the layout. Okay, and I think that's all I'm going to talk about. So just think about the layout. When you're writing the match or conditional, don't just write the code over there. And then there is a special offset, we can use offset 0, which gives us the type information. Now, when we have this type information, we collect a lot of stuff. We can see that if you have a type, and if you have a type ID, like type ID for the boolean or the ID number for boolean or for a string or whatever, some class, we can see if it's at least the type of the at least the type of the branch, the type T1 or T2 of the branch. So we need to use the class name table or all this type hierarchy that we collected in the compiler, the compiling phase. We need to use that and then mix it together with the dynamic type of the object. Remember, not the static type of the object, the dynamic or the runtime type of the object. Use that. And if you use the static type of the object, we already know the type. For example, we can have a method that takes a type of any, but that's a static type of the object. Then we do the pattern matching, do this type case to find the type of the object, like if it's a T1 or T2. That's called the dynamic type of the object. So at the static type, the type of the object may be any, but at the runtime, the type of the object may be T1, T2, or null. So if that makes sense. So thank you, and make sure you complete the lab assignment and then submit it to Canvas. And thank you.